So, over the past several decades, the STEM policy community has really agonized over whether there were enough STEM degrees being produced for the STEM jobs available, or during the outsourcing era, whether there were enough STEM jobs for the degrees available. But I'd like to take my 10 minutes on this stage to suggest that perhaps there's a different way to look at this problem, and that's by looking at fundamental skills. Oops. Now, degrees were always supposed to be a proxy or a label representing the skills you had underneath. But in fact, they are two very different things, as demonstrated by 40 years of research in the industrial psychology literature, spanning literally over 1,000 different studies across hundreds of different occupations. If you look at what predicts on-the-job success better than any other metric, it is something called an ability composite, which is the combined scores of 3 different skills tests. Now, they could be any 3 skills that are relevant to the job. They could be applied math, reading, spatial, or they could be listening, observation, locating information, which is the ability to read charts, graphs, and diagrams. But you take 3 of those scores and combine them, and you get something that predicts on-the-job success with a correlation coefficient of about 0.5. Now, it's not as good as 1, which would be perfect predictability, but there is nothing that's 1. And the best we have is this metric. But what's very interesting is that this metric is 5 times better at predicting on-the-job success than level of education or degrees. But what do we use as employers to figure out who we're going to hire? The degree. There is something that skills predict that a degree doesn't. There's something in these tests that predicts something different than the tests we take in school. What is it? It turns out that these tests, whether they're in the text domain, the numbers domain, the diagrams domain, what they're looking for is your ability to move from the unknown to the known, to figure things out. Increasingly harder questions look for things like, can you sort through more and more irrelevant information and discard what's irrelevant? Can you take what's remaining and organize it in a chained logic sequence so that you can arrive at an answer? Can you detect underlying patterns or pull out information that is somewhat obscured? These are critical thinking skills, or problem-solving skills, as we would call them in lay language. And it turns out that they're not really taught in school, because in school you're given the known and expected to reproduce the known. But in work, these skills are critical. Every day on the job is different. You have to figure something out, whether it's a new customer, a new product. And we can tell from the data we've collected on over 1,800 individuals in New Mexico that about 10% of an individual's ability to exhibit these skills is actually related to the years in school, and 90% comes from somewhere else. Now, STEM jobs are different from normal jobs because they have 4 of the 6 to 8 underlying basic skills in much higher required quantities. So in the area of reading, in the area of observation, in the area of locating information, which is the charts and diagrams things I was talking about, and in the area of applied math. Those are 4 skills that are required in STEM jobs in much higher levels than in normal jobs, and in fact, they define what is STEM. But if you look at, again, what these tests are probing and which predicts on-the-job success so well, what's missing? Well, observation isn't even taught in school at all as a skill, but it turns out to be critically necessary, from testing equipment to performing scientific experiments. Applied math is very interesting. We teach something called math in school, but in the workplace, what you have to do is take a real situation and figure out how to solve it with math, which means the very first step is you take that real situation and you code it into math, and then once you get it down on the piece of paper, you solve it. That first step, seeing the world as math and coding it into math, is completely missing from the school curriculum, which is why, even though the applied math tests only go through 6th grade math, they get to the fractions part of things, most people don't do too well at them because they can't code the real situation into the math before they solve it. And then finally, we have locating information, which I can tell you in New Mexico is a key deficiency, and in fact, it's probably a key deficiency across the nation. We think we teach people how to read and understand charts, graphs, and diagrams because they get it in science classes, they get it in math classes, but we don't really teach it systematically the way we teach phonics so people can read. And so people leave not really being able to grasp the charts and diagrams they have to work with. I'll give you a case study from a company in New Mexico that produces and repairs heavy-duty equipment for the oil and gas industry. They hire a lot of welders. but they were having problem after problem with the equipment not being welded correctly, and they couldn't understand it because they only hired certified welders. Well, we sent in a job profiler, an expert whose job it is to identify exactly which skills and which quantities are needed for a job, and he came back and said, you realize, to the hiring manager, that this job requires a level 6 in locating information, that the charts and diagrams these welders are trying to use to figure out how to do their welds actually can be understood by only 0.1% of all New Mexicans and less than 1% of people around the nation. If you want someone who can weld from these diagrams, you're going to have to hire someone who's a level 6 in locating information, which means, go to the architectural design firm, and the guy who's making 6 figures there, you're going to have to, convince him to come work for your welding company at a fraction of the salary. Or you have 2 other options, perhaps a little more reasonable. One is to dumb down your diagrams to the point where your welders can actually understand them. The other is to train your welders so they can finally understand the diagrams they're trying to weld from. And I can give story after story on this particular topic. But overall, we become so enchanted in New Mexico with the idea that there's a better way of looking at people's fundamental ability to perform STEM jobs, that we've started to encourage employers to, instead of just saying we want this or that degree, to say, we want someone who is a 5 in locating information, a 5 in applied math, a 5 in observation, or whatever it is that the specific job requires, and actually put that in the want ad when they're hiring people. Now, there are stations throughout the state where you can go get tested on these specific skills, and you can bring your scores to the employer and submit them along with your resume, just like you would go get tested on the SAT and submit those scores to a college to get in to a degreed program. And what's happened is very interesting. First of all, employers start finding people they never knew existed. All the people are complaining, well, there are no STEM degreed people, there are no STEM degreed people. You start finding the local cab driver who came in from Eastern Europe and actually has 30 degrees of STEM experience and actually can perform math better than the grad students. Or the guy in the maintenance department who's scoring a 7 in applied math that you never look twice at. People are there, but they don't necessarily have the right labels. And just to give you an idea of the impact on the company's bottom line, what we saw in New Mexico is completely consistent with what has been happening nationally with the few employers that have tried this approach. This slide is for Innovate Healthcare Systems in Northern Virginia. But overall, and you can look at the actual data on some handouts that are being given in the back, there is a 25 to 75% decrease in turnover due to using the skills-based hiring approach, a 50 to 70% decrease in time to hire via this approach, a 70% decrease in cost to hire, and a 25 to 75% decrease in time to train. Somehow, these tests are getting at something that's much better than the degree. And we think we're beginning to understand what it is. So, we're going to the next talk. So let me conclude by saying that there is a different way of looking at the problems that we've been struggling with. Maybe it's not a better way than looking at degrees, but it's a different way, and we can gain different insights from it. We can modify our educational approach through project-based learning, through curricula specifically designed for skills, and there are a number of them out there, in order to encourage our students to graduate with the skills they really need to perform on the job, and not necessarily just a label.